Welcome to the lesson about circles and tangents. In this lesson, we ask, what is a tangent, and how does the Pythagorean theorem help us work with tangents of circles? First, we'll look at the definition of a tangent line. A tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So usually you have lines that go through the circle. They would intersect at 2 points. However, a tangent only intersects at exactly 1 point of the circle. And if I was to draw a line, a radii, from that point that the tangent intersects on the circle to the center of the circle, that line would be perpendicular to the tangent line. If you think about a tangent in the real world, think about a discus thrower, somebody when you throw something with your arm, a ball perhaps, or a frisbee. If you spin an object in a circle and then you release it, whatever you're throwing, usually minus curveballs and air resistance and things like that, it will go in a straight line that is tangent of the circle that it was spinning around. So here's the formal theorem. If a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. And the point of tangency is simply the point on the circle that the line is tangent to. So the point that the line intersects on the circle, right there, that's the point of tangency. Another theorem about tangent lines, tangent segments to a circle from the same external point are congruent. So an external point is just a point that's outside of the circle. For example, the one you see here, point B. If I draw a line from point B and I draw it tangent to the circle, one here and one here, well, it just turns out that these two segments have to be congruent. They have to be. These are the only 2 points that you can draw a line from point B to be tangent. Some people think of this as the hat theorem because it looks like a hat on top of a head. If you connect the cord there from A to B, you got a little party hat on top of the circle. Here are just some common tangents. There are lines or segments that are tangent to more than one circle at the same time. So some examples, 2 external tangents, blue, or 2 internal tangents, black. And those are 2 completely separate circles. 3 common tangents, 2 externally tangent circles, meaning that they only touch at 1 point, and so this line is going to go through and it's going to run tangent both to circle A and circle B at the same time. And then you have 2 external tangents, and then 2 common tangents are if you have 2 overlapping circles. There is no internal tangent because the circles overlap. There is no in between there. And then 1 common tangent is if 2 internally tangent circles, which means that the 2 circles are tangent there, but the 1 circle is inside of the other circle. And so that's when you have 1 common tangent Zero common tangents, the only way that can happen is if you have two concentric circles. So concentric circles are circles with the same center, or if you have one circle floating inside the other circle without touching. A secant is a line that runs through 2 points. So any other line that runs through is called a secant. And in case you didn't know already, the part or the section of the secant that is inside of the circle, so this part of it, AB here, that's called a chord. So a little vocabulary review. The whole line that runs through is a secant. That line is secant to the circle. A couple theorems for secants. If two secant segments are drawn to a circle from the same external point, so I got one external point over here, and I draw two lines secant to other points on the line. The product of the length of one secant segment and its external part is equal to the product of the length of the other secant segment and its external part. So what that's saying is B here, this secant part right here, B, actually this whole thing, B, this whole secant, times the external part of it, which is just A from here to here, is going to be the same, it's going to be the same proportion as C here times the whole thing, D. And if a secant segment and tangent segment are drawn to a circle from the same external point, the product of the length of the secant segment and its external part equals the square of the length of the tangent segment. And that's kind of just an extension of that first theorem that we just talked about above, because technically if you say we want to take this whole thing, A, times the external part, well, that's the whole thing, A, and that's going to be equal to C times B. And so that's where the second theorem here that you see is derived from. So you got B times C equals A squared, because the whole thing is external here because it is a tangent line. And so don't worry about these numbers, by the way. These numbers don't mean anything. That's just the order they were in the resource that I found them. So don't worry about those. These are just generic theorems. So that's the lesson. I hope you learned a lot. Go ahead, try your homework. I hope you can tell me what a tangent is and how we can use the Pythagorean theorem to help us work with tangents of circles.